Welcome again, Wildcats. Now, before we get started, I made a mistake on the table of contents where I put the year, and the year is kind of irrelevant. So if you want to take a few seconds to erase that and update it with the day, the month, or the day, Monday, Tuesday, the month, and then the date. And then once you have that updated, we're looking at Monday, November 13th, factor by grouping, and that's on page 32. So go ahead and update and fix your table of contents. All right, now your table of contents is updated. Let's take a look at the notes. All right, factor by grouping on page 32. All right, factor by grouping. Okay, step 1, group terms. Step 2, factor common monomials from each group. Step 3, factor out the common binomial. Step 4, factor the DCF or the difference of squares. All right, so if you would update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, examples on page 32. And let me zoom in, see it better. All right, example 1. Factor the polynomial with grouping. And again, it's going to be helpful to draw some lines to keep your work organized. All right, now step 1, group terms. They're already grouped. You want the highest powers together, okay, and they are, and then the x and the number here, okay? Now it says factor common monomials from each group. Now the common monomial here is 3 because 12 and 9 are divided by 3, and x squared because x cubed and x squared have an x squared. So that's 3x squared. That's your common monomial. Now, the easiest way to think about when you factor it out is what do you have to multiply this now to get 12x cubed? Well, the answer to that is 4x. Because 3 times 4 is 12 and x squared, and x to the 1 is x cubed. And then minus 3, because negative 3x squared times negative 3 is a negative 9x squared. Okay? Now let's factor out the common monomial from this group. In this case, the only thing you can factor out is a 1. So we factor out a plus 1, and we still have 4x minus 3. Now, in factoring by grouping, if these are the same, then you can factor by grouping. If they're not, then you can't factor by grouping. Okay, so since 3x squared is multiplied by 4x minus 3 and 1 is multiplied by 4x minus 3, we can actually combine these. And so then that's 3x squared plus 1 times 4x minus 3. Just gotta straighten that out a little bit. All right. Now remember, at any point as I'm going over the examples, if you get stuck, leave it blank, and then I'll go over that again in class, okay? All right, let's look at example 2. All right, example 2. Step 1, group terms. What's the group? The highest exponents are together, and the x and the constant are together. Step 2, factor common monomial. So I see that these are both divisible by 4, and I can take an x squared from both. So that common monomial is 4x squared. Again, when you factor out, you think about, what do I multiply this by to give you 12x cubed? Well, the answer to that is 3x. And then what do you multiply 4x squared to give you 4x squared? Well, that's plus 1. Okay, now just like example 1, we want the same here, and you notice that we already have that, so we can just factor out a plus 1, and we'll have 3x plus 1. Since these are the same, we know it's factored by grouping, and so we're going to now put the 4x squared and the 1 together, so that's 4x squared plus 1 times 3x plus 1. And we know we're done because there's no greatest common factor and there's no difference of squares in either one of those. All right, let's take a look at example 3. All right, step 1, group terms. I know it doesn't look like it, but they're grouped. And you'll see why in just a few seconds as we go through it. Now we factor out the common monomial. And before we do that, we want to draw some lines. All right. So here it looks like the largest number that's divisible by both 140 and 60 is 20. Okay. And these both have an x, so we can factor out an x. And then the way you understand what goes here is you think about, what do I multiply 20x by to give you 40xy? Well, the answer to that is 7y. Because 7 times 20 is 140, and y times x is xy. And same thing here, what do you multiply 20x by to give you negative 60x squared? And the answer to that is negative 3x. Because 20x times negative 3x is negative 60x squared. Now, whenever you factor out the next monomial, you're looking at to try to get this to be 7. So you think about, well, is there something that we can divide 168 by to give 7? And the answer to that is yes, 24. 168 divided by 24 is 7. Okay? And so then when we multiply, we know that 24 times 7y is 168y. And then what do you multiply 24 to give you negative 72x? Well, the answer to that is negative 3x. And you know you can factor by grouping when this and this are the same. So this can be written as 20x plus 24, 7y minus 3x. All right. Now we're into the last step, factor the greatest common factor of difference of squares. In this case, we have a greatest common factor, and 20 and 24, the largest number divisible by that is 4, so we can actually factor out a 4. And so 4 times 5x is 20x, and 4 times 6 is 24. And then there's nothing you can factor out from there, and they're not difference of squares, so you are done. All right, let's take a look at example 4. All right, example 4. All right, so step 1, group terms is already grouped. And then factor common monomial. So you think, what's the biggest we can take out of here? And so this is a 1 and 5. We can take out a 1, but that doesn't matter. We can take, but it looks like we have an x cubed and x squared, so we can take out a 1x squared. And then what do you multiply 1x squared to give you 1x cubed? Well, the answer to that is x. And what do you multiply 1x squared to give you 5x squared is plus 5. Now remember, when you're factoring out the next one, you're trying to get x plus 5. So you're thinking about, well, what can you factor out of it? It looks like negative 4 from both. Okay, so we factor out a negative 4. Well, negative 4 times x is negative 4x, and then negative 4 times a positive 5, okay, is negative 20. So it looks like these are the same. So we know we can factor by grouping. So now we do 1x squared minus 4 times x plus 5. Now, you can't forget about the last step. It says factor the greatest common factor of difference of squares. Here, this is actually a difference of squares because we know positive 2 and negative 2 gives negative 4. So this is actually x minus 2, x plus 2 times x plus 5. Now, if you were like, whoa, Which is, what did you just do? Put a little note, and I'll show you in class why x squared minus 4 is x minus 2 times x plus 2. Otherwise, let's move on to example 5. All right, and again, we want to start out by drawing lines. All right. Now, I'm just going to give you a heads up. Example 5, a little interesting. So, but again, don't be afraid to stop as I'm going over and say, you know what, I have a question about this. I want Mr. Luke to go over it in class, okay? All right. Step 1, group terms, once they're grouped. Step 2, factor common monomial. So it looks like we can factor 3 from both and then x squared. Again, the way you figure what goes here is you think about what do I multiply 3x squared to give you 3x cubed? The answer to that is 1x. And then what do you multiply 3x squared to give you negative 21x squared? And that is negative 7. Now remember, you're trying to get 1x minus 7 in the next one, so you think, well, what can I factor from here to get that? In this case, it's negative 1, because negative 1 times a positive x is negative 1x, and then negative 1 times a negative 7 is a positive 7. Okay, and then you group them together. And this one actually isn't as bad as I thought it was. I think it's, oh, it's number 7. That's, yeah, number 7 scary. Now, there is no difference of squares, and there's no greatest common factor from either, so we are done. All right, so finish that up, and let's look at example 6. All right. Ooh, number 6 and 7 are, I think, the scariest problems on this page. All right, so example 6, group terms, they're grouped, and then factor common monomial. So it looks like we can factor a 4 from here and then x squared. And then what do you multiply 4x squared to give you 8x cubed? The answer to that is 2x. And then what do you multiply 4x squared to give you negative 4x squared is a minus 1. And you remember, you're trying to get 2x minus 1, so you think about what can we factor from here. In this case, it looks like 1525, we can factor out at 25. So what do you multiply 25 to give you negative 50x? And so we're actually going to change this to, we're actually going to factor out a negative 25 because we want this to be a positive 2x. And so a negative 25 times a positive 2x will give us a negative 50. And then negative 25 times a negative 1 will give you 2x minus 1. Because remember, when factoring by grouping, these have to be the same. Now we group these together, so that's 4x squared minus 25 and 2x minus 1. Wait a second. I put a box around that, but I forgot step 4, factor the greatest common factor, or the difference of squares. These are actually a difference of squares, and you know that because 2 squared is 4 and 5 squared is 25. So this can be written as 2x minus 5 times 2x minus 5, or plus 5 times 2x minus 1. And if you looked at that, what just happened, remind me in class and I'll go over and kind of show you how you make the connection between this and that. All right, let's take a look at example 7. All right, group terms, they're grouped, and then factor common monomial. Here, these are both 3, so we're going to factor out 3. But before we do that, draw some lines. All right, so then we can also factor out an x squared, so that's 3x squared. And then you ask yourself, what do you multiply 3x squared to give you x cubed? It's 1x. And then what do you multiply 3x squared to give you 3x squared? It's positive 1. And then we want 1x plus 1, so we're going to factor out a negative 3 here. And that gives us 1x plus 1. Because negative 3 times 1x is negative 3x. Negative 3 times 1 is negative 3. These are the same, so we know we can factor by grouping. So then you get 3x squared minus 3 times 1x plus 1. Now, again, you want to factor the greatest common factor or the difference of squares. So first here, we can factor the greatest common factor of 3. So then that's 3x squared minus 1, 1x plus 1. But now we have a perfect square because we know 1 squared is 1. So this can be written as 3, 1x minus 1, 1x plus 1, 1x plus 1. All right, last example. Let's look at example 8. All right, we want to group terms. They're grouped. Factor the greatest monomial. It looks like here, the greatest we can factor out is a positive 1x squared. So then 1x squared times 4x gives us 4x cubed. And then 1x squared times a negative 1 gives us negative 1x squared. And then here, we can factor out 2. Actually, no, we can factor out an 8. And that leaves us x minus 1, which I'm glad this happened. I was worried if we didn't have one. But notice these aren't the same. So it's not factorable by grouping. And since the statement said, the assignment stated factor by grouping, then we're going to state that. All right. And again, at this point, you have 2 routes to go. If you understood the example, start working on the assignment. If you have some questions, then note which questions you want me to go over in class, and we'll discuss those and work those together. With that, have a wonderful Wildcat morning.